Hello everyone. Today I would like to share a small project of mine with you. This is a cooling fan controller for my inverter. Previously, I used an 8 centimeter fan that would run continuously when the inverter was working. It cooled very effectively, but it was very noisy, especially at night. So I designed a small circuit to control the cooling fan. The fan will automatically start working when the temperature exceeds 40 degrees Celsius and will increase its speed as the inverter heats up. I have shared the complete file for this project. You can download it and use the Gerber file to place an order on the JLCPCB website. It only costs $2 for 5 PCBs. You can also order PCBA at a very affordable price.
This is the soldering path of the chip. How would you route it? If the number of pins is low, you can route traces directly outwards. However, when there are many solder pads on the chip, it becomes difficult to do the fan-out. So we drill vias to transfer the traces to other layers. Note that we first extend a trace from the pad before drilling the via. While routing becomes much simpler, you still need to route at least one trace from pad to via, so there can still be issues with pads being too dense or too numerous to route effectively. If we directly place the via directly on the pad, there's no need for additional trace before via. But this can lead to solder wicking away through the hole during soldering, causing defects or cold solder joints. Via in-pad technology addresses these issues. We still place the via on the pad, but then fill it with resin and plate it with copper. The surface shows almost no trace of this, and soldering is as reliable as with a regular pad, saving on routing, optimizing board size, and also enhancing thermal conduction. If you're looking to optimize your routing and save time, you can take advantage of free via in-pad service. Try it now and save time.
Unlike usual, today I will make the PCB at home. I do not encourage you to do the same because you will need to purchase chemicals to etch the copper board. These chemicals are quite expensive and very harmful to both you and the environment. Additionally, you will need a drill to make holes in the PCB and many other tools, and the PCB quality will also be quite poor. The only advantage is the time, as it takes about 2 hours compared to 1 week if you order PCBs from JLCPCB. Please consider all these factors carefully. Here I will coat the PCB with a layer of tin. This will protect the PCB from oxidation. It is quite similar to the Hazel process used by JLCPCB. Of course, the quality of a homemade PCB is much worse. This is the final product. When compared to a professional PCB, the difference is enormous. Next, just solder the components onto the PCB. All the components are easy to find and can be purchased at any local store. If you don't want to solder them yourself, you can place an order with JLCPCB. They will manufacture the PCB and solder the components for you. I will test it before installing it in my inverter. You can see that it works very well. It can control a fan with a maximum current of up to 4A. The input voltage ranges from 12 to 24 volts. This is my inverter system with an EV 100-hour battery and a 60-watt MPPT charger. It is currently 8 a.m. The charging power is approximately 800 watts, and the inverter power is around 350 watts. The inverter is quite cool, and you can see that the cooling fan is not working at all. It is now 9 a.m. The charging power and inverter power have increased significantly. The inverter temperature has reached 45 degrees Celsius, and the cooling fan is running at its lowest speed. At noon, when I use the air conditioner, the cooling fan speed will gradually increase. In the evening, the cooling fan will almost stop. My project has been a complete success. Thank you for watching my video. Don't forget that I am sharing this entire project. Click on the link in the video comments to download the files.